Hello students, good morning all. So welcome to CBC 2, the last lecture today, right? And after this lecture, we will be pending with one topic, BIN. So first of all, understand, don't get panicked for the topic left. It is only the bridge course, right? And for your knowledge, for your preparation, not to have that incomplete, I will record it separately and will upload in our channel, Resonance Hyderabad official channel. Okay, na? So don't get worried about that, and to whatever extent it is completed, be perfect up to that, and remaining topics can be done later. Okay, na? So now, in yesterday's rules in calculating, in finding out the oxidation number, up to 7 points we have discussed. If you remember, up to 7 points we have discussed, right? So the 8th point is, in neutral compounds, the sum of oxidation numbers is 0. In neutral compounds, the sum of oxidation numbers will be equal to 0. Suppose if I take a neutral molecule, NaCl. This is a neutral molecule. In this, the oxidation state of sodium is a +1, plus oxidation state of chlorine is, oxidation number of chlorine is -1. So +1 plus -1 becomes 0. So this is what the neutral molecule case. The sum of oxidation numbers of all the atoms in a neutral molecule will be equal to 0. What if it is charged? That is a subpoint. In complex or polyatomic ions, the algebraic sum of oxidation numbers of all the atoms, right? Suppose if 2 hydrogens are there, every hydrogen oxidation number should be considered. 6 oxygens are there, each oxygen oxidation number -2 should be considered, right? So it is not that for all the 6 oxygens you will write the oxidation number once. For every atom you have to write individually the oxidation number, right? So the sum of all that oxidation numbers will be of the ion will be equal to charge of that ion. If it is positively charged, then the sum also will come to that charge, and if it is negatively charged, the sum of oxidation numbers will be equal to that negative charge. So this point we have to understand. So in order to understand it better, let me take one empty slide and explain you. Suppose if I am having NH4 plus. This is a positive ion, na? So in this, the sum of oxidation numbers of nitrogen and all the 4 hydrogens together will be equal to +1, right? So that is -3 is the oxidation number of nitrogen plus +1 into 4 is equal to +1. So -3 plus +4. This itself is +1. Yes or no? Right or wrong? So in this manner. But you may have the doubt that how sir has written nitrogen directly -3. Maybe we know for hydrogen in general it is a +1. Oxygen -2. Fluorine -1. Alkali metals +1, alkaline earth metals +2. But how do we know that for nitrogen here it is -1? It is just a previous knowledge. If it has to be calculated, we are not aware of it, then we can assume that its oxidation number to be X. So what is according to the rule? The sum of oxidation numbers will be equal to the charge of the species, na? So I will assume that nitrogen oxidation number is X, because I do not know, is it a +1, +2, +3, +4 or -1, -2, -3, -4, what it is, I do not know. So X plus +1 into 4 is equal to overall charge of the species, that is unit positive charge. Now X plus 4 is equal to +1, X is equal to -3. So in this manner we will calculate what is the oxidation number of that element whose oxidation number is not known. Then another case is SO4 2-, let us assume. SO4 2-. In this case, the species is anion. Overall, it is negatively charged. So sulfur is actually +6, You just confirm whether the sum of oxidation number of all the atoms is becoming equal to -2 or not. +6 plus total 4 oxygens are there. So each oxygen is a -2 into 4. So how much it will come to? +6 plus -8. Yes or no? So how much it is equal to? It is equal to -2, na? So that is what the -2 here. So the sum of oxidation numbers of all the atoms in a neutral molecule will be equal to 0. In an anion will be equal to that negative charge. In a cation will be equal to that positive charge. So this is one important point we have to understand. Now coming back to another important point. This is a very important point actually. This is a very important point. Okay. So what this point is saying is, if the element belongs to transition elements, we know what are transition elements. The entire periodic table by Niels Bohr, it is divided into 4 types. First one is representative elements, second one is transition elements, third one is inner transition elements, and fourth one is inert gases. Right? And within representative elements, we are having 2 parts. One is S block and P block except inert gases. So that was the previous classification, right? So according to that, whatever transition elements are there, like a scandium, niobium, tantalum, iron, cobalt, nickel, copper, zinc, mercury, osmium, all these are the elements which will be having variable oxidation state. Sorry, zinc will not have variable oxidation state. Its oxidation state will be fixed only because it is a non-transition element. 3D10 element is a non-transition element. Zinc only will be having single oxidation number, that is +2 only. The remaining elements in the transition elements will be having variable oxidation numbers, which means that they will be having more than one oxidation numbers. 2 or more oxidation numbers will be there. Therefore, that is what is called as variable oxidation states. Variable oxidation states. The highest oxidation state, and this is for the representative elements. Representative elements, already I told you, S plus P block, S plus P except inert gases, right? Inert gases. So the highest oxidation state, oxidation number of representative element is the group number for the first 2 groups. Group number for the first 2 groups. This is just before only I have told. What are the first 2 groups? First one is alkali metals whose group number is 1 and their oxidation number is also +1. And the second group is alkaline earth metals whose group number is 2 and their highest oxidation number is +2. So group number itself is the highest oxidation state for the first 2 groups. Then what about the remaining elements of representative element? That is the P block elements of representative elements from 13th to 17th group. It is the highest oxidation number will be 10 minus number of valence electrons, right? 10 minus, this is a group number -10. Group number -10. I think it will be there here, you see. Group number -10. Group number -10, right? Suppose if you say like halogens are there, like chlorine is there. Chlorine, what is the group number? 17. And how many valence electrons will be there in chlorine? Not only chlorine, in any of the halogen element. It is NS2, NP5 and 7 valence electrons will be there. So 17 minus 10 is what the +7 oxidation, highest oxidation number. 17 minus 10 is what the number of valence electrons present. That itself is the highest group number. Okay, na? Following the long form of the periodic table for the other groups. Thus, the highest value of oxidation number exhibited by an atom in an element generally increases across the period in the periodic table. That means when you are moving from left to right, we already started with alkali metal with oxidation number +1. So from +1, sodium, let us assume, right? From in third period elements, from sodium whose oxidation number is +1, from there if you are moving towards the right of the periodic table, you will be reaching to the last element in the representative elements, that is chlorine, whose oxidation number is +7. So from +1 to +7, oxidation number increases, right? in a period. In the third period, the highest value of oxidation number changes from, this is what just now I told you, +1 to +7, as indicated below in the following compounds. You can see this is the example to explain how the oxidation number is gradually increasing from left to right in a period, right? Sodium +1, example is given, sodium bromide, magnesium sulfate +2, aluminium in AlCl3 is +3, silicon in SiCl4, silicon tetrachloride is +5, +4, phosphorus in phosphorus pentoxide is +5, sulfur in SF6 is +6, chlorine in perchloric acid is +7, right? So this is these are the general rules to be followed while calculating the oxidation number, right? Now let us go to the next point. That is a procedure for calculating the oxidation number. If you remember, already just before only I have already explained you what is the procedure in calculating the oxidation number of an atom in a molecule. Just that atom whose oxidation number you want to calculate, assume that its oxidation number is X, not +X or -X, X only. That itself will indicate what oxidation number will be coming, right? So let us take the example here. Let us take the example here in which the oxidation number of sulfur we have to calculate in hydrogen sulfide. First of all, what we should know is for which element we have to calculate oxidation number. Oxidation number is for a particular atom, not for the entire molecule. This is a very, very important point everybody have to understand. Oxidation number is a property of one particular atom in a molecule or ion. If that ion itself is a single atom ion, then you can say that its oxidation number itself is the atom's oxidation number or ions, overall ions oxidation numbers, like Cl- is there. -1 is the oxidation number of chlorine itself, because the one and only atom present is chlorine only, right? Na? But if you say sulfate ion, SO4 2-, you cannot give oxidation number of entire SO4 2-. You have to give the oxidation number, you have to assign an oxidation number particularly to sulfur and also to each and every oxygen. So this is one important point you have to understand. The second point is that whatever compound is given, its exact molecular formula should be known. This point I have told you earlier also. Wherever you see the names of the compounds, you try to write their molecular formulas. This is the best way in getting a grip on all the compounds we are having in inorganic chemistry. There are a limited number of molecules in inorganic chemistry. So if we are very familiar with these names and their formulae, you will be saving a lot of time during the examination, especially the NEET students who have to run behind the time during the examination, right? So oxidation number of sulfur in hydrogen sulfide, the first point is sulfur's oxidation number to be calculated, right? Second point is that the formula of molecule is to be written H2S, and in this H2S molecule, whose oxidation number we have to calculate, sulfur's oxidation number we need to calculate. Then the third point is that to write the sum of oxidation numbers equal to charge of that species. This is a neutral molecule that overall charge is 0. So each hydrogen will be of +1 into 2, right? Plus sulfur oxidation number we do not know. So I assume it as X is equal to the sum of oxidation numbers of all the 3 atoms will be equal to 0 here, right? Now you calculate this, that you will be getting +2 plus X is equal to 0. X is equal to -2. So sulfur oxidation number is -2 here, right? So hope you have understood how to calculate. Now let's see some more examples. Oxidation number of nitrogen. Here it is capital N, typing mistake, nitrogen. Oxidation number of nitrogen in NO3 minus has to be calculated. Let us assume oxidation number of nitrogen is X, right? Na? So X plus each oxygen is -2 into such oxygens 3 are there is equal to overall it is an anion and the negative charge is minus 1. So, x minus 6 is equal to minus 1, x is equal to minus 6 going on that side, it will become plus 6. So, that results in plus 5. So, plus 5 is the oxidation number of nitrogen. And coming to chlorine here, x plus minus 2 into 4 is equal to minus 1. Well, because overall charge is minus 1 here. So, x minus 8 is equal to minus 1. X is equal to minus 1 plus 8. Therefore, x is equal to plus 7. Understanding? So, should I give you 1 or 2 minutes time for you to calculate oxidation number of chromium in Cr2O72 minus dichromate ion? So, dichromate ion here is, try it yourself. Take a minute of time and try it yourself. This is dichromate ion. Calculate. Okay. So, I think you have completed, right now. Simple examples only. So, here you need to calculate the oxidation number of chromium. So, I will assume it as x, but such chromiums too are there. So, it will become 2x plus minus 2 into 7 is equal to overall negative charge. So, 2x minus 14 is equal to minus 2, 2x is equal to minus 2 plus 14, 2x is equal to plus 12, x is equal to plus 6. So, each chromium will have plus 2 oxidation number. 2 chromiums are there, plus 6 plus 6. Next, calculate the oxidation number of the metal atom in complex ions. Complex ions. These are some special compounds, special ions which will be discussed under an exclusive chapter called coordination compounds in 12th standard inorganic chemistry. Very beautiful chapter, excellent, right? Concepts are there. So, if you see in this type of compounds, how to calculate it. Here also actually there is no difference. Same rule will be there, but there are cases sometimes that two atoms, you can see here, two atoms together are present in one bracket. So, already whatever that group of atoms are there in the round brackets, their sum of oxidation numbers itself is the charge of that species itself, that is a Cn minus. Cyanide ions are there. Like that, how many cyanide ions are there? 6 cyanide ions are there. Already the sum of the 2 carbon and nitrogen oxidation numbers is equal to minus 1. So, just you can consider minus 1 itself to be the oxidation number. Overall, whatever charge is there, that itself can be considered, because even you consider individual oxidation numbers also, ultimately it will come to the same answer, right now. So, what we will do here is iron oxidation number need to be calculated. So, that is considered to be x plus each cyanide ion is having a charge of minus 1, like that, 6 cyanide ions are there. Such 6 cyanide ions are there, and the sum of all of their oxidation numbers is equal to minus 4. So, x minus 6 is equal to minus 4, x is equal to minus 4 plus 6. Therefore, you can say x is equal to plus 2. So, iron oxidation number in this coordination compound is plus 2, right? And previously we have discussed for Cr2O72 minus, you only have solved it. So, similar to that is permanganate, MnO4 2 minus, permanganate. Permanganate ion. So, in permanganate ion, I assume manganese oxidation number to be x plus minus 2 into 4 is equal to minus 1. X minus 8 is equal to minus 1. X is equal to minus 1 plus 8 is equal to plus 7. Manganese oxidation number is plus 7 here, right? So, easy only, na? So this is one table in which you need to calculate oxidation number of individual atoms here. You can practice it later also, and if you are having any doubt, you can ask later, right? This is a BrF3. This is C6H12O6, right? This is Na2B4O7 borax. This is chloroform, carbon monoxide and carbon dioxide. Bicarbonate, carbon suboxide, carbon suboxide, tribromo octabromide, tetrathionate ion. Okay, so these are the species up to 9. They are common only. You can practice by yourself. Within the sheet also the solutions are given. Let me explain one of the molecule from these things, right? So going to first, which one you want? Let me explain the first one itself. Carbon suboxide, C3O2. C3O2. In carbon suboxide C3O2, there are 3 carbon atoms, right? And it is asked to calculate the oxidation number of carbon only. But there are 2 possibilities here. Maybe all the 3 carbon atoms are having same oxidation number, that you calculate any carbon's oxidation number, it will come to same answer. That is the first possibility. But the second possibility is that among the 3 carbon atoms, maybe the carbon atoms have different oxidation numbers. Different oxidation numbers. Within the same compound, if same element is having different atoms with different oxidation numbers, then the 2 concepts will arise. One is to give whatever carbon 1, carbon 2, carbon 3 is there, to give their individual oxidation number. C1, what is oxidation number? C2, what is oxidation number? C3, what is oxidation number? That is what is called as individual oxidation number. Individual oxidation number. Suppose he is asking in the question, find the oxidation number of central carbon atom. Then the C2 carbon he is talking about, therefore you can easily calculate it. Suppose if he is asking what is the oxidation number of carbon in carbon suboxide, which carbon has to be considered? There are 3 carbon atoms in total. So which carbon you will consider? It is when he is asking the question in the second way, that is what is the oxidation number of carbon in general, not specifying which carbon atom it is. That means he is talking about, he is asking average oxidation number of all the oxidation numbers of 3 carbon atoms. So there are 2 points comes here in such cases, that is individual oxidation number, average oxidation number. Individual oxidation number and average oxidation number. Whatever we have discussed till now before were individual oxidation numbers only, because average is not needed, because that particular atom is only one present. So straight away you are calculating oxidation number of that atom. But here there are more than one atom of same element which has a different oxidation numbers. So there the point issue will come, that is it he is asking individual oxidation number or he is asking average oxidation number. Okay, so let us calculate both of them for this molecule. First of all, let me write the structure of this compound, right? C3O2. You can understand oxygens are 2 only, but carbons are 3. So carbon should be at the center, and you should also know that carbon is a tetravalent and oxygen is a divalent. What does it mean? Carbon is tetravalent means it will be forming 4 bonds, whereas oxygen is a divalent means it will be maximum forming 2 bonds. There are rare cases like H3O+, in which oxygen will form 3 bonds. That is a maximum covalency, but here it is a divalent. In general, oxygen is divalent. So in satisfying this tetravalency of carbon and divalency of oxygen, generally that atoms whose covalency is higher will be the central atoms, and the atoms whose covalency will be lesser will be the surrounding atoms or outside atoms, right? Neighboring atoms. So here to say, like, I can understand the basic point that the atom should be like this. because carbon is tetravalent, na? So it has to be at the center. Now, oxygen divalent to be satisfied by forming a double bond here and double bond here. So oxygen's issue is over. Now coming to the carbon, it is tetravalent, but here this carbon is forming 3 bonds only, making it as 4. So the tetravalency of this carbon is satisfied. One more double bond is kept. So this carbon also 1, 2, 3, 4 bonds are there. This carbon also 1, 2, 3, 4 bonds are there. So all atoms are satisfied with their valency, covalency, right? Now, let us assume for understanding purpose, this is a C1, C2, C3. Just labeling I am giving, C1, C2, C3. Now, we know that oxygen's oxidation number is -2, or else, to understand also, among the 6 electrons, 2 of the electrons it has participated into sharing, right? This oxygen also, among the 6 valence electrons, 2 of the electrons it has given into sharing, right? Now, carbon has 4 valence electrons, right? So let me take them in another color. Carbons will have 4 valence electrons. These are the 4 valence electrons of first carbon, second carbon 4 valence electron, these, and third carbon 4 valence electrons are these 4. Got a point, na? Now, oxidation number, yesterday and the day before yesterday also we have discussed. Oxidation number gives the difference in number of electrons the atom is having before bonding to after bonding. Now, this molecule will be broken heterolytically because it is having oxygen more electronegativity of oxygen greater than carbon. This point already we know this one. Oxygen is more electronegative than carbon. Therefore, we have to break it here, right? And we have to break it here. Got it? Now, this carbon, first carbon lost 2 electrons and third carbon also lost 2 electrons to their respective oxygens. Now, how do you break these bonds? These bonds are present between similar or like carbon atoms. Like atoms are there. Like atoms. First carbon is forming 2 double bonds. Second carbon forming 2 double bonds. Third carbon also forming 2 double bonds. So, like atoms, electronegativity also will be same, that when you break, you have to break them homolytically. Symmetrically, you have to break them. Now, you can understand that first carbon, C1 carbon, before this molecule formation, it was having 4 valence electrons. But after the molecule is formed, how many it is getting now? Only 2 electrons. Means net 2 electrons it is losing. So, for which first carbon oxidation number will become +2 only. +2. Right? Coming to the third carbon also same scene. Na? So, this also will be having +2 oxidation number. Tell me the oxidation number of central carbon. Central carbon, before forming this compound 4 valence electrons. How 4 valence electrons? Carbon atomic number is 6. Electronic configuration 1s2, 2s2, 2p2. These are the 4 valence electrons I am talking about. So, 4 valence electrons are there, and after molecule formation also it is getting 4 valence electron. There is no loss or no gain. Therefore, its oxidation number will be 0. Its oxidation number will be 0. That means, among the 3 carbon atoms, 2 of the carbon atoms are having +2 and +2 oxidation numbers, and the middle carbon atom is having 0 oxidation number. That is what variable oxidation states. Variable oxidation numbers for the same element, different atoms are having different oxidation numbers here. Different oxidation numbers. Now, the question comes when it is oxidation number of C1 and C3 is +2. Individual. Individual oxidation number of C2 is 0. Understood up to here? Individual oxidation numbers are like this, +2 and 0. Then what is average oxidation number? Is sum of oxidation numbers of all the atoms. First carbon +2, second carbon 0, third carbon again +2, divided by 3 carbon atoms are together. So +4 divided by 3. +4 by 3 is the average oxidation number of carbon. Average oxidation number of carbon. He is not mentioning which carbon. If it is mentioned which carbon, that is individual oxidation number. If it is not mentioned which carbon, that means it is average oxidation number. And one more point you can understand here, individual oxidation numbers can be integers, positive or negative integers, or even 0 also. And average oxidation number can be fractional also. This is one point you have to understand. So hope everybody understood this concept, right? Individual oxidation number and average oxidation number. And the second molecule what he has given, I think Br3O8. Is it that only? Tribromine octaoxide. I think that only, that if you consider bromine, the structure will come to like this. 3, 6, 8 are there total, that this comes to this one. So this bromine oxidation number will come to +6, and this bromine oxidation number also will come to +6, but this bromine oxidation number will come to +4. So if it is average oxidation number, then 6 plus 6, 12 plus 4, 16. 16 divided by 3 will be the average oxidation number. So we have to understand what is he asking. What is he asking? Okay, na? So if you want, you can take the screenshot also. Okay, chalo. So let's get back into this example, and that also similar one, S4O6 2 minus also similar case. In the notes in your material, structure is given. If you want structure, I will draw it, see, for your but there are some students even do not have the material. Understand it, don't be negligent like this, that these many classes are happening, but still you are not working on how to get the material. Okay, so that is not correct. Ultimately you will be the loser, not your father or mother or teacher. Okay, na? So this is the structure of the species. So in this case terminal sulfurs will be having +6 oxidation number, and middle sulfurs will be having 0 oxidation number. So all 4 sulfurs together, it is a +12 by 3, +12 by 4, that is +3 will be the average oxidation number, +6 and 0 are the individual oxidation number. So in this manner you have to understand this. So going to the next point, the maximum oxidation number of an element is equal to the maximum oxidation number of an element is equal to the number of valence electrons present in that atom. This is many a times we have already checked this one, and the minimum oxidation number is equal to the number of electrons it is required. Maximum is by losing all the electrons. Suppose a chlorine is there. Just as an example, let's take chlorine. For this point, chlorine, what is the electronic configuration? You know, atomic number is 17, that's its electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p5, 3p5. So in this one, the highest oxidation number, maximum number, is when all the electrons in the valence shell are lost. How many valence electrons are there in the valence shell? 2 plus 5, 7. So when all the 7 electrons are lost, its oxidation number will come to +7. Its oxidation number will come to +7. I think it is not visible here. Little lower I will write. It will be +7, right? And if what will be the minimum oxidation number? Minimum oxidation number is when it is having how many electrons deficiency in reaching to the next noble gas configuration. It is already having 7 valence electrons. It is deficient of only 1 electron in reaching argon configuration. By losing 7 electrons, it will be reaching neon configuration before noble gas, and by gaining 1 electron, it will be reaching next noble gas configuration, that is argon configuration. So, the minimum oxidation number is equal to -1. Minimum oxidation number is -1. So, in this manner you can consider, that is what the point here is saying. So, this is 8 minus 7 here, that becomes to -1, where n is the number of valence electrons present in the shell. The oxidation number of metals in amalgams. Do you know what are amalgams? Amalgams are mixture of some metal with mercury. Mercury amalgams, right? Sodium amalgam, potassium amalgam, like that, iron amalgam, gold amalgam, whatever it is. So, some metal with mercury is amalgam. Not only these, in amalgams, both metals will be having 0 oxidation number. Not only in amalgams, even in alloys also, the metals will be having 0 oxidation number. Ignoring the impurities, the metals will not be losing any electrons, so that their oxidation numbers will be considered as 0, right? Even not only in amalgams and alloys, even in metal carbonyls also, metals will be having 0 oxidation number. Nickel tetracarbonyl, iron pentacarbonyl, chromium hexacarbonyl, they will be having 0 oxidation number. Why do they have 0 oxidation number? See, when nickel tetracarbonyl is broken down, you will be getting neutral carbon monoxide molecules. So, if this species is neutral, then obviously this also should be neutral, because some is already neutral. Understanding? So, these are all having 0 oxidation states. Next, in oxoacids of the same metal, the greater the oxidation number of the element, the greater is its acidic strength. This point also will come little later, but as the point is mentioned here, let us take the example. Simple point it is, for one particular element in the given oxoacid series, as the oxidation number of that particular element increases, its acidic strength also will increase. It becomes more and more stronger acid, like HOCl, hypochlorous acid, HCl O2, chlorous acid, HClO3, chloric acid, HClO4, perchloric acid, right. So, in all these 4 compounds, HOCl is the one in which chlorine has +1 oxidation number, here chlorine +3, here chlorine +5, and here chlorine +7, right. So, +7 oxidation number, highest oxidation number, therefore, perchloric acid will be strongest acid, then chloric acid, then chlorous acid, and then hypochlorous acid. Okay. Next example, another one is also there. If you have already observed H2SO3, sulfurous acid, in which sulfur oxidation number is +4, and sulfuric acid, in which sulfur oxidation number is +6. So, therefore, sulfuric acid is more acidic than sulfurous acid, nitrous acid, nitric acid, phosphorus acid, phosphoric acid, right. So, higher the oxidation number of the central atom in that oxoacid series, the acidic strength also will be gradually increasing. Next point, if a compound contains 2 or more atoms of the same element, they may have the same or different oxidation states. That point already I have explained you, that is what individual oxidation numbers and average oxidation number. Okay. So, CrO5, this is one special compound. CrO5, chromium pentoxide, will have butterfly structure. Butterfly structure. How is it a butterfly structure? Is this chromium will be having bonded with 5 oxygen atoms. These 2 are like the wings, and this is like the beak. So, butterfly structure for the chromium pentoxide, and here also this is a peroxide, right? If this is a peroxide, in peroxides we know oxygen will have -1 oxidation number, and this is a normal oxide, -2 oxidation number. So, -1, 1, 2, 3, 4, 5, 6. So, -6 is there. To balance it, chromium will be having +6. Understanding? So, in this manner we can give the oxidation number of chromium in this example. The next, magnetite is Fe3O4. There is a ore, very important iron ore called magnetite. Maybe some of you in ICSC, you may get this information in 10th standard, metals, ores or right, minerals. So, magnetite is a combination of magnetite Fe3O4 is a combination of two oxides, that is FeO and Fe2O3. You can add both of them, 1 iron plus 2 irons, altogether 3 irons, and then 1 oxygen, 3 oxygen, altogether 4 oxygen. Fe3O4 is a mixed oxide. Mixed oxide. In which this is a ferrous oxide and this is a ferric oxide. Okay. And in a ferrous oxide, iron oxidation number will be, in a ferrous oxide, iron oxidation number will be +2, and in ferric oxide, iron oxidation number will be +3. Why is it a +3? 2x minus 6 is equal to 0, 2x is equal to +6, x is equal to +3. Okay, na? So, there are 3 irons here, one will be having +2, this will be having +2, and here the 2 irons are having +3 and +3. So, these are the individual oxidation numbers, right, individual oxidation numbers. Suppose if he is asking average oxidation number, what should I do? 2 plus 3 plus 3 divided by 3, that is 8 by 3 plus 8 by 3. So, this is the average oxidation number plus 8 by 3, that is what he has written here. Understanding? Next, valency, differences between valency and oxidation number. Valency is the combining capacity of an element, whereas oxidation number is a charge, whether it has lost electrons or gained electrons, and how many lost, how many gained is what oxidation number, whereas valency is what is the combining capacity of that atom with the surrounding atom. That means with how many atoms it can bond. Valency is only a number, whereas oxidation number is a charge, that already we know it, right. Valency can never be 0, because if it can form 1 bond or 2 bonds or 5 bonds or whatever it is, whereas oxidation number can be 0, right. There is no loss or gain. Valency is always a whole number, then oxidation number may have a fractional value. In just before example also, plus 8 by 3 is a fractional number. Then variation of the valency of an element is limited, that means fluctuation is lesser, whereas oxidation number can be variable for same element, same atom in different compounds. Now, going to discussing that topic is over. Now, let us discuss its respective DPP also, right. Hope you have done this one. This is a homework of today. The oxidation state of selenium in H2SeO3. H2SeO3. So, in H2SeO3 selenium oxidation number we have to calculate. So, each hydrogen is +1 into 2 plus x plus -2 into 3, altogether is equal to 0, right. So, +2 plus x minus 6 is equal to 0, x minus 4 is equal to 0, x is equal to +4. This is the answer. Got na? Next, the oxidation number of the oxidation state of phosphorus in NaH2PO4. NaH2PO4. What is the procedure? To add the sum of all the oxidation numbers equal to 0, because it is a neutral molecule. plus 1 plus 1 into 2 plus x plus minus 2 into 4 is equal to 0. 1 plus 2 plus x minus 8 is equal to 0. X minus 5 is equal to 0. X is equal to plus 5, right. So, that is this, right. The next one, the oxidation state of sulfur in NaHSO4. All these are similar type of compounds, NaHSO4, right. So, plus 1 plus 1 plus x plus minus 2 into 4 is equal to 0. So, 1 plus x minus 8 is equal to 0, x minus 6 is equal to 0, x is equal to plus 6, x is equal to plus 6. Hope you are also solving along with me, right. So, then H4P2O7 phosphorus, H4P2O7, this is a pyrophosphoric acid. Pyrophosphoric acid. In this one, plus 1 into 4 plus 2x plus minus 2 into 7 is equal to 0. So, this is a 4 plus 2x minus 14 is equal to 0, 2x minus 10 is equal to 0, x is equal to 2x is equal to 10, x is equal to plus 5. So, each phosphorus will have an oxidation number of plus 5 here. So, then going to next compound K2MnO4, not KMnO4, right. K2MnO4 is a potassium manganate and KMnO4 is a potassium permanganate. So, understand the difference. He is asking about potassium manganate, right. So, coming to this one, each potassium, because it is an alkali metal, alkali metals oxidation number is plus 1, right, only plus 1 in the combined state. Plus 1 into 2 potassiums are there, plus x plus minus 2 into 4 is equal to 0. So, plus 2 plus x minus 8 is equal to 0. So, this x minus 6 is equal to 0, x is equal to plus 6, and here you will be getting x is equal to plus 7, okay na? So, x is equal to plus 6, you see plus 7 is also given, just thinking that some of us may get confused. Oxidation state of oxygen in calcium peroxide. This is one special case. This is not calcium oxide, calcium peroxide. What is calcium oxide? CaO. This is calcium oxide, and in calcium oxide oxygen is minus 2, therefore calcium will be plus 2, whereas in peroxide oxygen is a minus 1, minus 1 into 2 minus 2, so overall calcium will be plus 2. So, whether it is wherever calcium is present or alkaline earth metal is there, alkaline earth metal is a second group element is there, like a beryllium, magnesium, calcium, strontium, barium, wherever it is plus 2 oxidation number only, there is no variable oxidation number, right. So, calcium peroxide it is. So, x plus minus 1 into 2 here, till now we were taking minus 2, but this is minus 1 into 2 is equal to 0, understand it. So, x minus 2 is equal to 0, x is equal to plus 2, okay na? Next, oxidation state of boron in NaBH4, NaBH4. In NaBH4, oxidation state of boron will be plus 1 plus x minus, here also one important point is there, boron and hydrogen. When you compare boron and hydrogen, hydrogen is more electronegative than boron. Electronegativity boron is less than hydrogen. This is one important point we have to understand, right? So, hydrogen will have -1 oxidation number here, +1 plus x plus -1 into 4 is equal to 0. So, 1 plus x minus 4 is equal to 0, x minus 3 is equal to 0, x is equal to plus 3, that is this one. Got it? Then next, oxidation state of sulfur in H2S2O7, pyrosulfuric acid, H2S2O7, pyrosulfuric acid, In pyrosulfuric acid, +1 into 2 plus 2x plus -2 into 7 is equal to 0, right? All similar procedure, 2 plus 2x minus plus minus 14 is equal to 0, 2x minus 12 is equal to 0, 2x is equal to plus 12, x is equal to plus 6, all similar type of examples, plus 6. The oxidation state of sulfur in KAlSO4 twice 12H2O. This is one little complex example, right? So, let us see how to solve this one. KAlSO4 twice dot 12H2O. This dot 12H2O is 12 water molecules present as hydrated species. In the crystal lattice, in the gaps, these water molecules will be present, that they will be bonded with aluminum also here, right. So, if you remove them, the compound will become KAlSO4 twice, right. Now, here for which element he is asking oxidation number? Sulfur, na? It is very simple also. You break them, that this will become 1 potassium ion, 1 aluminium ion. Aluminium is always +3 oxidation number, alkali metals always +1 oxidation number, and 2 sulfate ions, SO4 2 minus, right. Now, within the sulfate sulfur oxidation number we have to calculate, right. So, I will consider sulfur as x plus each oxygen -2 into 4, overall it is -2 charge. So, x minus 8 is equal to -2, x is equal to plus 6. This is the answer. Next, plus 6. Next, the average oxidation state of carbon in carbon suboxide. This already we have discussed, na? The terminal 2 oxygens will get a +2 charge and middle oxygen 0. 2 plus 0 plus 2 divided by 3, that is a 4 by 3. That already we have discussed. Then next, average oxidation state of chromium in CrO5 +6, that also completed. The oxidation state of oxygen is -1 in which of the following? In Na2O2, sodium fixed oxidation number, that is a +1. So, as a 2 sodiums are there, +1 into 2, that is a +2, right. So, if 2 sodiums together it is +2, 2 oxygens together it should be -2, but here 2 oxygens are there. So, each oxygen should have -1 oxidation number. So, this is only the answer, this is only the answer. Coming to second one, KO2, potassium oxidation number cannot be variable, it is only +1. So, both oxygens together it is -1. So, 2 oxygens are there, but total it is -1 only. So, each oxygen is -1 by 2. This is what is called superoxide, potassium superoxide, that also we have already discussed, right na? Next, KO3, potassium ozonide. This is KO3. In this potassium ion K plus and O3 minus. All 3 oxygens should together should get -1 oxidation number. So, each oxygen average oxidation number will become -1 by 3, -1 by 3, -1 by 3. This is potassium ozonide. And here we know oxygen will have -2 oxidation number, therefore, this also will not be the answer, only first one. Then The oxidation state of hydrogen in metallic hydrides. In metallic hydrides like sodium hydride, potassium hydride, calcium hydride, this will be sodium plus 1 hydrogen, sodium plus 1 hydrogen minus 1. Here also hydrogen minus 1. Here also hydrogen minus 1. So, in all metal hydrides, hydrogen will have minus 1 oxidation number only. The next, oxidation state of chlorine in ClO4 minus, this also already we have calculated, it is plus 7. Oxidation state of chromium is 1412, sorry, 1412 2 divided by 2, so that is plus 6. This also already we have calculated. This also calculated in carbon monoxide. Oxygen is minus 2, na? So carbon should be plus 2, and in carbon dioxide, each oxygen is minus 2, therefore carbon should be plus 4. Plus 2 and plus 4. Here in option D you see plus 4 and plus 2, reverse is also given. So we have to be careful in what sequence it is asked. In the same sequence answer should be searched for. Okay. Then oxidation number of oxygen in ozone. Ozone is something, it looks like it is in an elemental form. So in an elemental form, generally what we assume that the oxidation number of each atom to be 0, but actually in ozone molecule, actually it is like an unsymmetrical molecule, that the different oxygen will have different oxidation numbers. Suppose if you write the structure of ozone like this. So here now you see here, when you break this bond, homoletically it will be broken, that earlier it was having 6, now also it will be getting 6. So oxidation number of this atom will come to, oxidation number of this atom will come to 0. Whereas coming to this oxygen and this oxygen, if this bond is broken, you will break it like this, right. Now this is having 1, 2, 3, 4, 5, 6, 7. 7 electrons are there. Before how many electrons? 16th group element, 6 valence electron, but after 7 are there. That is, it will be having minus 1 oxidation number. And coming to this oxygen, 1, 2, 3, 4, 5 only. 1 electron it is having lesser, therefore it is plus 1. So the 3 oxygen atoms will be having different oxidation numbers here, 0, plus 1, minus 1. That is what you have to consider, 0, plus 1, minus 1. This is the answer. So one of the important example, be careful. Then what is the average oxidation state of nitrogen in NH4NO3? Actually, average oxidation state he is asking, therefore you can eliminate these two, because average means single value, na? If it is individual oxidation numbers, I can eliminate option C and D and can go between A and B, but he is already asking average oxidation number, so I have to make it as average, right. So what is it within ammonium nitrate, NH4NO3? First of all, this ionic compound I will break into cation NH4 plus and anion NO3 minus, and here nitrogen oxidation number X plus plus 1 into 4 is equal to plus 1. So X plus 4 is equal to plus 1, X is equal to minus 3, and coming to here, X plus minus 2 into 3 is equal to minus 1, X minus 6 is equal to minus 1, X is equal to plus 5. So this is the oxidation number of nitrogen. So that is a minus 3 plus 5, minus 3 plus 5. This is also minus 3 plus 5. But actually it should not be, at least it should be given reverse, minus 5 plus 3 should be given. So that is in the similar way. So now let us say in whatever sequence they are present. First nitrogen is plus minus 3, second nitrogen is plus 5. First nitrogen is minus 3, second nitrogen is plus 5. Sorry, this is average, na? So that is nothing to do with this one. Now the average oxidation number is plus 5 minus 3 by 2. So 5 minus 3 plus 5 minus 3, how much? Plus 2, na? Plus 2 by plus 2, 1 plus 1. But there is no answer here. Five minus 3, 2. 2 by 2, 1. Two nitrogens are there, na? 2 by 2, 1. So average oxidation number is plus 1. I don't think there is an answer here, or it may be, depending on the answer given. Is he not asking average but asking individual oxidation number? If he is asking individual oxidation numbers, both will become correct. And to say in a sequence, if it has to be written, then it is a minus 3 and plus 5, minus 3 and plus 5. Option A will come to answer in that case. So just check your material, how is the question given, accordingly you can answer. Suppose if it is average oxidation number, there is no answer. If it is individual oxidation number, more appropriate will be option A. That's it. Okay. Then going to the next question, what is the average oxidation number of sulfur in Na2S6O6? Is it Na2S6O6? Oh, I don't think it should be Na2S6O6. Let me try to write the structure. S double bond O, double bond O, ONA, S double bond O, double bond O, ONA. Oh. Here he is asking average oxidation number. Okay. So here this is with the sodium, let us assume this is also with the sodium. So here when this bond is broken, oxygen only will get both the electrons, and when this bond is broken also, oxygen only will get both the electrons. So oxygen along with its 6 valence electrons, it is gaining 2 more electrons, this one and this one, electron of sodium and electron of sulfur. So altogether this oxygen is minus 2 and this oxygen will be of minus 2. Over, na? This is the first case. So sodium is plus 1, this sodium is plus 1, oxygen is minus 2. Then coming to this sulfur, if this is broken like this and this is broken like this will have plus 1 oxidation number, because earlier 6 were there, now it is having 5 only, 1, 2, 3, 4, 5, right. So plus 1 is the oxidation number of this sulfur, plus 1. This also will have plus 1, right. Then coming to intermediate sulfurs, 0, na? 0, 0, 0, 0. So average oxidation number of sulfur will be 1 plus 0 plus 0 plus 0 plus 0 plus 1 divided by, how many sulfurs are there? 6 sulfurs are there, 6, that is 2 by 6 or 1 by 3, plus 1 by 3, understanding, plus 1 by 3 should be the oxidation number, but I have the doubt in the molecule. Na2S6O6 generally I haven't seen, so that might be the mistake here. So we don't know what is given as the answer here, so accordingly you can check it later. Next, what is the stock notation of cuprous oxide? Stock notation is what? Commercially indicating how that compound should be written, right. Cuprous oxide as indicates lower oxidation number, IC indicates higher oxidation number. This is one point you have to understand. So CuO, cuprous oxide, sorry, Cu2O na, Cu2O cuprous oxide and CuO cupric oxide. Why? The reason is that in Cu2O 2x है ना, 2x minus 2 is equal 0, 2x is equal to plus 2, x is equal to plus 1. Copper oxidation number in Cu2O is a plus 1, whereas here x minus 2 is equal 0, x is equal to plus 2, x is equal to plus 2. So, here it is plus 2 oxidation number. So, higher oxidation number is ic oxide, cupric oxide, lower oxidation number is Az oxide. So, this can be written in a Roman number, copper 1 oxide, copper 1 oxide. This is the scientific notation of the oxide. This is the common name, and this is the scientific name, copper 1 oxide. Element, metal proper name, then its oxidation number in Roman numbers in square brackets, and then round brackets, and then anion, copper 1 oxide. So, with this we complete the discussion of this DPP, and we are left over with the BIN, which I will record and upload in the channel, and hope you have studied, listened to the entire CBC 2 session and took your notes properly and revise it before coming. And if you are having any doubts, you can still WhatsApp me through this number. Right, and or in your respective center, always our faculty team will be available. So, just you can approach the center you have enrolled for and you can clarify your doubts. The next physics class will start from 10:20 AM onwards, right. So, all the best. Thank you.
ठीक है. Good morning to all of you. So, let us continue. Yesterday, I was discussing about work, power, and energy. Just some basic you take, and then we'll continue with the problems. Okay, we'll continue with the problems, but a bit recap. Formulae for work done. If a constant force acting on a body and body has displacement S, suppose I have a body and on this it is kept on a horizontal surface, a smooth surface. You have applied force F and displacement is in this direction at an angle theta. Okay, check the figure. Then this is work done by a constant force. Work done by a constant force is dot product of force and displacement. For solving the problems along with concept, you need this fundamental basic formula for work done. This is equal to W equal to mod F mod S cos theta. F mod means magnitude of force multiplied by magnitude of displacement, and theta is the angle between force and displacement. This is first fundamental formula, right? If work is not being done by a constant force, if work is done by a variable force, then first technique is take force as a function of S, plot a graph, take displacement on x-axis, take force on y-axis. Suppose my graph is like this, and we want to calculate work done for displacement. If I take position vector S1 and S2, suppose I want to compute work done for this range, just take this area. Yeah, this will be giving you work done. It means that if work is being done by a variable force, then area of force displacement graph will give you work done. Next technique, to calculate work done by variable force, what you do, you have to integrate F dot ds and whatever value of limits of integration they will give you. I know most of you who have never taken foundation courses, they may not be knowing integration, so you cannot use this at this time. Yeah, when you'll be coming near to us, in the beginning in mathematical tools, we'll be teaching you whatever math in physics we need, your physics teachers will teach you. In that, fundamental formulas of differential calculus, integral calculus, all they will teach you, then only they will start teaching you physics. More than 3 weeks to 4 weeks we have allotted only for mathematical tools. So, for calculating work done, okay, by variable force, to use the formula integration f dot ds, you cannot use now for solving the problem. Before that, you have to learn integration. Clear to you? At this time, whatever problems we have, either homework or classwork in our CBC, all will be related to Fs cos theta. Clear? So we are starting with problem number 1. A porter lifts a luggage of 15 kilogram from the ground and puts it on his head. So you have a luggage, mass they have given you 15 kilogram, and height they have given you 1.5 meter. Calculate work done by him on the luggage. Now, the man is exerting force upward, but beta, here there will be two situations. He is lifting it with constant velocity, he is lifting it with constant acceleration. In both cases, work done will be different. If you consider that body is lifted with constant velocity, then whatever force he is applying, that will be equal to m into g, right? But if he is lifting up with acceleration a, then force he will apply m in bracket g plus a. When they simply say you that the person is lifting the body up to certain height, it is pre-understood that body is lifted with constant velocity. Then at the place of F, we will be taking mg, we will equate F equal to mg. Then in this case, your work done will be equal to F into h, means mg into h. Work done by the person will be positive. He is facing resistance, right? No, the force is acting upward, displacement is also acting upward, theta is 0 and cos 0 is 1. The work done is positive, work done by the porter will be positive, and it is equal to mgh. Now m is how much? M is 15, G you have 10, H is 1.5, this much joule. This is 15 into 15, 225, 225 joule. This will be the answer. Check it. Are you understanding? All the problems in our CBC will be based on work done by a constant force. So either you are using for this kind of problem where body is lifted against gravitational pull, you will be using either mgh or m in bracket g plus a into h. If man is lifting with acceleration a, suppose this is the body and you are lifting it from ground to height h. So you are applying force here. If you are moving with constant velocity, then you will be taking F equal to mg. If you are lifting it with acceleration a, then your F will become m g plus a. Your formula will become then, for this mgh, for this it will be mg plus a into h. Clear to you? Understood? And the opposite also is possible. If man is keeping the body on the ground, now he is loading the body with constant velocity or with constant acceleration. If he will be simply keeping it with constant velocity, you will be taking mgh, work done by man will be negative. But work done by gravitational force will be positive. You'll tell why, sir? Gravitational force is acting downward, na? And displacement is also acting downward. So in that case, work done by the man in loading the body from certain height, work done by the man is negative. But work done by gravitational force will be positive. Here, when you are lifting body up, work done by porter, work done by the person is positive. But work done by gravitational force will be negative. Why? Gravitational force is acting in downward direction. And body has displacement in upward direction. The angle between gravitational force and displacement is 180 degree. Then work done by gravitational force will be negative if you are lifting body vertically up. But work done by the person who is lifting the body vertically up will be positive. In this case, porter has done positive work and magnitude of that work done is 225 joule. Tell me, all of you understood clearly now? I hope you understood. Now, let us move to next problem. A force of 10 Newton displaces a body by 5 meter. F is 10 Newton displaces a body by 5 meter. The angle between force and displacement is 60 degree. Theta 60 degree. They're asking you calculate work done. Lot of practice is there beta in our CBC book. We'll make you practice lot of problem. First we'll make you master of concept here in our resonance, and then we'll give you lot of problems for practicing. Same concept, so many problems. And then slight change in the models of problems so that you should be perfect in using concepts. Now, F they have given you, displacement they have given you, theta they have given you, and they say you calculate work done by the force. What you will use? Fs. If I want to draw the figure, so here is a surface. On this body, a force is acting. Displacement here, this is theta. So work done will become equal to F mod S mod magnitude cos theta 10 5 cos 60 degree. It is 50 1 by 2 25 joule answered. All the quantity they have given you in international system of unit. So in SI, the unit for work done is joule. So work done is simple 25 joule. I hope all of you understood. Let us move now to next problem. A student pulls a toy train through a distance of 12 centimeter while playing in the garden. A child is playing. A student may have any age. Okay, no. The child is playing with a toy. He has a toy train and he is pulling through a distance of 12 centimeter. So they have given you 12 centimeter. In SI system, it is 12 10 to the power minus 2 meter. If the work done by the child is 60 joule, so work done by the child is 60 joule. When 1000 Newton force, F, 1000 Newton force is applied, then find the angle made by the string held in the student hand with the horizontal. Again, draw the figure. You have body, toy train you will have to take. You will have toy train Okay, no? You will have a toy train. Train they are telling you, na? So here one engine you will show, and with the string you are pulling it. If this type of problem will be there, I can also ask you tension, okay, no, in between any two compartment of the train. And now, here is F, here is theta, here is displacement. W will be equal to what they are asking you, angle. They are asking you theta, how much? So W, F, S cos theta. W 60, F 1000, S 12 10 to the power minus 2 cos theta. Am I right? So now let it be 60 or here this 10 to the power minus 2 and 2 0 I will remove. It will become 120 cos theta. So what you are getting? Cos theta 60 by 120, 1 by 2. Theta will become 60 degree. Clear to you? Understood? Easy, no? Yeah? Answer is 60 degree. Now, let us move to next problem. I am moving to next problem, number 4. Work done upon a body. I have told in the beginning only yesterday, maybe work done, maybe power, maybe energy, potential energy, kinetic energy, total energy, all these are scalar quantity. The work done upon a body is, they are giving you, it is a vector quantity, it is a scalar quantity, A and B both are correct, none of the above. Answer will be, work done will be a scalar quantity. So answer, it is a theory based question beta, this is a scalar quantity. Clear to you? Let us move to next question. Work done is always positive, always negative. It is positive, it may be negative, it may be 0. I have taught you, right now? But again, let me recollect. Here, if I have a body and you are applying force F, displacement along positive x-axis, this angle theta, you take 4 quadrant beta. Okay, no? So this is first quadrant, second quadrant, third quadrant, fourth quadrant. Easy way to remember. If theta is in first or fourth quadrant, what will happen? Excluding, not including, excluding theta 90 degree and 270 degree. If you are not considering 90 degree and 270 degree, and you take theta in first and fourth quadrant, means there must be a component of force along the direction of displacement. Then work done will be positive. Clear to you? If theta is 90 degree and 270 degree, your work done is 0. If you take the value of theta in second and third quadrant, means force is present in second or third quadrant, then excluding 90 and 270, then there will be a component of force opposite to the direction of displacement. Then work done will be negative. Clear to you? Very easy. First and fourth positive, second and third work done will be negative, 90 degree and 270 degree, work done will be 0. So here your answer, work done, can be positive, may be negative, or it may be 0. Clear to you? Let us move to next question now. No work is done. When there will be no work done, either F0 or S0 or theta 90 or theta 270. Theta 90 or 270 means force will be acting at right angle to displacement. So you just check here what they are giving you. A nail is plugged into a wooden board. When you are plugging the nail, you are exerting force on nail. And nail will be penetrating into wooden board. Means there will be some displacement of nail along the direction of force. So there will be work done. A box is pushed along a horizontal floor. When you are pushing the box, there will be a component of force along the direction of displacement. There will be work done. There is no component of force parallel to the direction of motion. There is no component of force perpendicular to direction of motion. No work is done if I take fourth. No work will be done if force will be acting perpendicular to direction of motion. So guaranteed your answer will be C. We may correct a bit C. We can say that no work is done when there will be no component of force parallel or anti-parallel to direction of motion. Because if parallel to direction of motion, work done is positive. If you take anti-parallel, opposite, theta 0 you take, work done positive. Theta 180 degree you take, work done will be negative. So, you have to consider no work will be done when there will be no component of force parallel or anti-parallel to the direction of motion. So, answer for this question will be C. Now, let us move to next question. A body at rest can have. You know that if there will be speed, body will not be at rest. If it will have velocity, it will not be at rest. Am I right? If it will have momentum, momentum is mass into velocity. Mass is a constant quantity. If a body has linear momentum, it means body has velocity. Guaranteed then, answer, a body at rest can have energy. What kind of energy? It should have potential energy, energy hidden in the configuration of physical system. So here, a body at rest can have energy. Answer will be number 4. Clear to you? Understood? Now, let us move to next question. A block of total mass 5 kilogram. So they are giving you mass 5 kilogram is being raised vertically upward. You are raising the body vertically upward with the help of a constant force F. A constant force F. And see here, they have given you acceleration 2 meters per second squared. Clear to you? Body is rising not with constant velocity, it is rising with an acceleration of 2 meters per second squared. Find the work done due to this constant force if block is raised by h. They have given you 2.5 meter. If I take F, this will be M. You know, real force mg downward. Body is raised up. So pseudo force M into A, you will have to take downward. So F will become mg plus A. So work done will become mg plus A into H. M 5, G 9.8 plus A they have given you 2 meter per second squared. H they have given you 5 by 2, 2.5. That is 12.5. 5 into 5, 25 by 2. 12.5 into, this will become 11.8 joule. I hope you will multiply it. Correct? Yes or no? Clear to you? Now, let us move to next question. This will be the answer. Next, how much work is done by a man who tries to push the wall of a house but fails to do so? If there is a wall, it depends upon what kind of wall it is. Okay, no. In a village, any wall is there, okay, no, and a very strong man is there, then he can break the wall also, then he will do work. But generally you take a rigid wall and then man is pushing it. If man will be pushing the wall, what will happen? Right? Will the wall move? Wall will not move. What will be displacement of wall? 0. Work done is how much? Fs cos theta. If S is 0, then complete Fs cos theta will become 0. How much work man will do? 0. Why? Displacement of wall is 0. Yeah? No need to do. Directly you can say the answer that man will do 0 work if he is pushing the wall. It does not mean he is not applying the force. He is applying the force. So remember Newton's first law when I was teaching you. And I have defined force from Newton's first law. Force is that external agency which changes or tries to change the initial state of the body. Initial state may be that of rest or uniform motion along a straight line path, means with constant velocity. Force, when it is acting, you cannot say that always it will change the initial state of the body. Force may change or may not change, but it will try to change, right? So you are exerting force on the wall, but wall is not moving. Force is acting, but still work done is not there. Why work done is not there? Because there is no displacement at all. Did you understand clearly? Yeah? Work done, final answer. Work done by the man is 0 because the wall is not being displaced. Work done is Fs cos theta, displacement is 0, so entire Fs cos theta becomes 0. Clear to you? We are already now on homework of work, power and energy. Class work I have completed. Now I am on homework. This one was number 1. Now I am on number 2. In which of the following cases the work done by gravitational force is negative? Okay? Work done will be negative when theta will be 180 degree. Means force and displacement, their directions must be opposite to each other. They have given you only 3 cases. A monkey is climbing up a tree. A man can also climb the tree. A monkey is climbing up a tree. A monkey is standing at the foot of a tree. A monkey is climbing down a tree. They are asking you work done by gravitational force. When monkey is climbing up, work done by monkey is positive. But work done by gravitational force will be negative. Why? Gravitational force on monkey is acting in vertically downward direction. And displacement is acting in upward direction. Angle between displacement and gravitational force is 180 degree. So work done will be negative. Answer for this question will be, when a monkey is climbing up a tree, work done by monkey is positive, but in the question they have asked work done by gravitational force, the work done by gravitational force is negative because theta, angle between gravitational force and displacement, is 180 degree. So for this question, your answer is A. Tell me, did you understand clearly? If you understood this, now let us move for question number 3. A body of mass m is moving in a circular path of radius r with uniform speed. This is a case of uniform circular motion. Okay, no? Very simple. You know that for a body to move on circular path, you need a centripetal force. So, if I take a circular motion, okay, no, and a particle is moving, its velocity will be in this direction, and in this direction a centripetal force is acting. You know centripetal force will be equal to mv square by r. It is acting towards the center. Someone should provide, okay, some force, external force should provide centripetal force. Is itself not a force. When you are moving on a curved path on road, frictional force is providing you centripetal force, right? When electron is revolving in circular path around nucleus in any atom, then electrostatic force acting between nucleus and electron is providing centripetal force to the electron to revolve in circular path. In chemistry, in Bohr's theory, you have studied about that. Clear to you? So, in uniform circular motion, this angle is 90 degree. Means the angle between force and velocity vector, or you can say displacement, is always 90 degree. Now, a body of mass m, they have given you the mass of the body, radius r, how much work is done on the body? I have told you theta 90 or theta 270. In both cases, work done will be 0. Right? Why? Cos 90 degree is 0. Cos 270 degree is 0. W equal to Fs cos theta. Fs mod F mod S cos 90 degree or cos 270 degree. Fs into 0 whole will become 0. So answer here, work done will be 0. You remember, when a particle will move on a circular path, work done by centripetal force will always be equal to 0. Let us move now to next question. I am now on question number 4. What is the condition for work done to be positive? I have taught you work done will be positive when theta, they must mention what is theta. Theta is the angle between force vector and displacement vector. I have told you when theta will be in first or fourth quadrant, means if theta is in between 0 degree and 90 degree, but not 90 degree, less than 90 degree, because at 90 degree it is 0, work done will be 0. So if theta is in between 0 degree and 90 degree, or theta is in between 270 degree and 360 degree, not included 270 degree, then there will be a component of force along the direction of displacement, and then work done will be positive. Here so many conditions they have not given you. They have given you less than 90, equal to 90, equal to 90, not possible, work done will be 0. Theta greater than 90, work done will become negative. Theta greater than 45 degree, this is true. If theta will be greater than 45 degree and less than 90 degree, then work done will be positive. But in these four, the better answer will be theta. If I have to select in these four one, I'll be selecting theta less than 90 degree. So answer for this question will be A. Clear to you? If you understood this, then let us move to next question. A locomotive exerts a force. Locomotive is exerting a force. So they have given you force, magnitude 7,500 Newton. Pulls a train 1.5 kilometer. So displacement is 1.5 into 10 to the power 3 meter. Calculate work done by the locomotive in kilojoule. Now you will have to remember that displacement is occurring along the direction of locomotive. In whatever direction locomotive is moving, in that direction train is moving. Then cos 0 is 1. When you will take cos 0, 1, what will be work done? Work done will be simply equal to F and S. So this will become 7500 into 1.5 into 10 to the power 3 joule. They are asking you answer in kilojoule. So this part, keep it as kilojoule. So this will become 750 into 15 kilojoule. Now, we'll have to multiply 105. Okay, no? Please check it. This much kilojoule should be the answer. Yes or no? 15 into 750. Okay? It will become 10550 kilojoule. I can take more also. If 3 you can take, 4 you can take. I can take 1, 2, 3. 3, 4. 1, 2, 3, 4. Okay, no? 500, 7500. Okay? I can take it as 1.055. Okay, no, 1, 2, 3, 4, 3, 7, 10 to the power 7 joule. I feel that this will be significant figure. If you consider, this will be more better answer. Okay, no? You will have to take 1.055 and 10 to the power 7. If you will take 10.55 megajoule also you can take. But kilojoule they are asking you. So this will become 10550 kilojoule. Clear to you? Now, let us move to next question. A force of 30 Newton acts on a body. The F, they have given you 30 Newton, guaranteed it is magnitude of force. Displaces it through 10 meter. Displacement, they have given you 10 meter. Calculate work done if displacement is along the force. Now again theta 0. Again W equal to Fs. No need to do. Directly you will say 30 into 10, 300 joule, answer. So W will be equal to mod F mod S 30 into 10 joule 300 joule. You can check displacement is along the direction of force. So theta plays very important role. Here theta is 0 degree. Cos 0 you have taken 1. So your formula simply become W equal to mod F mod S. Let us move to next question, number 7 now. A boy pulls up a bucket of water. So there is a bucket filled with water from a well 80 meter deep. So first I am taking H, it is 80 meter. Mass of the bucket along with water 25 kilogram. M, they have given you 25 kilogram. Calculate the amount of work done by the boy in kilojoule. Take G 10. If they are not giving you value of G as 10 meter per second squared, then it is pre-understood you will have to take G as 9.8 meter per second squared. Correct? So now, here again, question is, the boy is pulling the bucket with constant velocity or with constant acceleration. When they don't say anything, you pre-assume that boy had pulled the bucket with constant velocity. Force exerted by the boy in pulling the bucket up, you will be considering M into G. Or if you are pulling it up with constant acceleration, then your force will become mg plus A. So here W will be equal to mgh 25 10 80. Is it clear to you? And they are asking in kilojoule. Later on we will see. The kilo, what you do, 25 is there? No. Keep it 100 by 4 into 10 into 80. It is joule. Up now these 3 you take 1000. So it will become 80 by 4 and now it will become kilojoule. 1 kilojoule is 1000 joule. So it will become 80 by 4. So this will become 20 kilojoule. Clear to you? W equal to, you have taken mgh. Because they wanted answer in kilojoule, so I have taken 25 as 100 by 4 because I wanted to separate 1000. Okay, no? So this part 1000 I have taken to make it kilo, and only 80 by 4 I have kept, it will become 20 kilojoule. Now, this is the answer. Now, let us move to next question. An object of mass 2 kilogram is lifted to a vertical height of 1 meter. Find work done. Okay, no? An object of mass 2 kilogram is lifted to a vertical height of 1 meter. Calculate work done. अब object of mass 2 kilogram, M 2 kilogram lifted to a vertical height 1 meter. G, they have not told you. When they are not telling, you will have to take 9.8 meter per second square. Work done, mgh 2 into 9.8 into 1. So this will become 19.6 joule. Answer. Understanding? Same concept, multiple problems, so that your basic concept should become crystal clear. Ekdam clear. Okay, no? So many problems on same concept you are finding in our CBC book. An object of mass 2 kilogram, you are lifting to a vertical height of 1 meter, and they are telling you calculate work done. You have taken W, F into S, F, mg. The mg, S is H, mg into H. M they have given 2, G they have not given. When they are not giving you, you must take only 9.8 meter per second squared. For calculation purpose, when we take 10 meter per second squared, it is becoming more easier. And because objective based exams we are writing, so time plays very, very important role. Clear? Understood? MGH? Answer for this question, 19.6 joule. Let us move now to next question. I am now on number 9, homework. A force of homework on work power energy. Class work already I have completed. A force of 10 Newton acting on a body. The F mod 10 Newton. Body is displaced through displacement 2 meter, such that force makes an angle 60 degree with the direction of displacement. The better you draw a figure, it will be easy to solve. This one is F, this one is S. Angle between these two theta, and they have given you that makes an angle 60 degree theta. They have given you 60 degree, and they say you calculate work done. Work done is mod F, mod S, cos theta. So W will be equal to mod F, mod S, cos 60 degree, 10, 2, cos 60, 2 cancel, 10 joule. Answer. All quantities they have given you in SI. In SI, the unit for force is Newton, displacement meter, work done joule. So answer for this question, for this problem is 10 joule. I hope all of you have clearly understood. I am moving to number 10 now. Based on physics, work means effort, interview, achievement, get together. Based on physics, all these quantities, I feel that these are metaphysical quantity. Yeah, work done means, I think effort means force. Sometimes we are putting effort and we are not getting result, right? So effort is just like application of force. They are comparing a physical quantity from a metaphysical quantity. Interview, I don't think so. It is in no way related to my work done. Achievement, yes, you have put effort and you got some achievement. So in my opinion, not that much comparable. Metaphysical quantity and physical quantity, if you are comparing, there must be some relationship. Okay? For example, color of a shirt. Color, metaphysical. It depends upon wavelength. So I can compare wavelength from color of any object. Pitch, metaphysical quantity. It depends upon frequency. So I can compare pitch from frequency. Understood? Anyhow, because they have asked question, you will have to give answer based on physics. Work done means, I think it will be achievement. Okay, no? Whether, I don't think so that any metaphysical quantity is directly related to physical quantity in this question. Now, we are on number 11. Work done on a body when 4 alternate they have given, every alternate microscopically analyze. Work is done on a body when? Work is done on a body when? I told you there must be force acting on the body. There should be displacement of the body. There must be a component of force either along the direction of displacement or opposite to the direction of displacement. Only these 4 conditions are there. A force acts on the body, but the body is not displaced. A bit displacement is not there, so work is not done. Force does not act. Force is not there, work is not done. Force acts on a body in a direction perpendicular to the direction of displacement of the body. Theta 90, cos 90 0, work done is 0. The A is not there, B is not there, C is not there. All 3 are wrong. Guaranteed there will be 4th answer. Force acts on the body and the body is either displaced in the direction of force or opposite to the direction of force. So here my answer is D. Force acts on the body and body is displaced either along the direction of force or opposite to the direction of force. If it will be displaced along the direction of force, we will say work done is positive. And if it is displaced opposite to the direction of force, we will say that work done is negative. The answer for this question number 11 will be D bit. Now, let us move to next question. Force F acts on a body such that force makes an angle theta with the horizontal direction. Okay. And body is also displaced through a distance s in the horizontal direction. Then work done by the force. Fs cos theta we know. Okay, no? So many times I have drawn this figure. If I have a surface, body has displacement in horizontal direction, force is acting at an angle theta, then work done by the force, this is F dot S, vector F dot vector S, dot product of force and displacement, it will be Fs cos theta. The very first formula yesterday or today I have given you was this only, Fs cos theta. So answer for this question is B. Let us now move to next question. In the tug of war, work done by the winning team is, now in your school, perhaps you have taken part in tug of war. In tug of war, there is a rope, and there will be two teams of 5 to 10 boys, and this other side also 5 to 10 boys. And you are pulling the rope of the winning team, guaranteed will be pulling it along its own direction. In whatever direction he is applying force, in that direction rope is moving. So displacement is acting along the direction of applied force. Theta is 0. They are asking you winning team, not losing team. Okay, no? In the case of losing team, your displacement is acting opposite to the direction of displacement. So for the winning team, your work done is positive. For losing team, work done will be negative. And the reason is quite obvious. The reason is, for winning team, the angle between applied force and displacement is 0. For losing team, the theta will be 180 degree. Right? Rope will move in this direction. Suppose this side team has lost. They are exerting force in this direction. So work done by losing team is negative, and work done by winning team will be positive. The answer for this question is work done is positive. Let us now move to next question. I'm now on 14. In the tug of war, work done by losing team is, just now without seeing the question, I have given you the answer. In the case of losing team, the force exerted by losing team will be acting opposite to the direction of displacement. The angle between force and displacement 180 degree, cos 180 degree minus 1, work done will be negative. So for this question, answer is negative. Clear to you? Fundamental concept based question. Now I am moving to next question. Work done by the force of gravity when a body is lifted to a height h above the ground. So suppose this is ground. On the ground there is a body of mass m, and you are lifting it up. When you are lifting it up, then gravitational force is acting downward and displacement is occurring in upward direction. Work done by the force of gravity when body is lifted, displacement in vertically upward direction, right? And gravitational force is acting in downward direction. They are acting in opposite directions. So theta is 180 degree. So when we lift a body from ground, work done by gravity, work done by gravitational force will be negative. The answer here is negative. Is it clear to you? I think that so many questions on fundamental concept of positive work, zero work and negative work done they have given you. First thing, that there is no meaning of the word work. Always there is meaning of work done. Clear to you? Now, let us move to next question. I am now on question number 16. When work is done on a body. Later on, when you are coming here, I will teach you work energy theorem. W will be equal to del K. Actually, in my opinion, name should be work kinetic energy theorem. But they are keeping the name work energy theorem. Right now, whenever you are doing work on any body, its kinetic energy will be changed. When work is done on the body, its kinetic energy increases. When work is done by the body, its kinetic energy decreases. Right now, so when work is done on the body, they are asking you A, B, C, D. Let us analyze. It gains energy, it loses energy, its energy remains constant, none of these. When work is done on the body, its kinetic energy increases. So answer here is, when work is done on the body, it gains energy. Clear to you? Let us move now to next question. I am now on 17. Choose the correct relation. It is conversion of, unit of a physical quantity from one system of unit to other system of unit. Joule is the unit of work done in SI, International System of Units, and erg is the unit for work done in CGS system, centimeter, gram, second, system of unit. Simple. Why we will talk about units and dimensional formulae and all? I have not taught you, you have not learned in detail. So here, I want to convert only 1 joule now. So 1 joule, if I take work done is Fs, so 1 joule, F 1 Newton and S 1 meter. Of Newton into dyne you go. So Newton is separate. Newton is force, mass into acceleration. So 1 Newton, 1 kilogram, 1 meter per second square. Now CGS system you go. So this will become 1000 gram, a 100 centimeter per second square. So 10 to the power 5, this is becoming dyne. Now you are converting joule SI into CGS erg. So 1 Newton is 10 to the power 5 dyne. Am I right? Please check. Meter converted into centimeter, 100. Kilogram converted into gram, 1000. Okay, no? So this becomes 10 to the power 5. And meter, I have converted into centimeter. Your 1 dyne 1 centimeter is 1 erg. When 1 dyne force will act on a body, due to which body will be displaced by 1 centimeter along the direction of application of force, then you consider work done is 1 erg. So here you are getting 10 to the power 7 dyne centimeter is erg. So you are getting 1 joule is 10 to the power 7 erg. Let us move to next question now. Which one is not the unit of energy? See, just now we have seen erg is the unit of work done, it is the unit of energy. Kilocalorie. So, this is unit of energy. Kilocalorie is the unit of energy. Calorie, you already know, the unit for heat energy. Kilocalorie is the unit for heat energy. Okay, no? Kilowatt hour. Very nice question. Very famous. Electricity bill you are giving in kilowatt hour. In your house, electricity bill is coming, no? They are telling that 200 unit is consumed. Okay, no? So 1 unit, okay, no, will be 1 kilowatt hour. I will show you. Kilo is 1000. Watt, 1 joule 1 second. Hour, 36, 16 to 60 second. But at this second cancel. You are getting 36, 10 to the power 5 joule. 3.6, 10 to the power 6 joule. So kilowatt hour is also the unit for energy. What is watt? 1 watt is the unit for power. 1 joule by 1 second. Asking you not the unit of energy. Your answer will be watt. Clear to you? Now, let us move to next question. The work done in holding a 15 kilogram suitcase while waiting for a bus for 15 minutes. Or you wait for 2 hours also. Will there be displacement? There will be no displacement. You are waiting by holding a 15 kilogram suitcase either in hand or on your head, because there is no displacement. Okay, you are just holding it, so work done will become 0. Work done in holding any body of any mass for any time will be 0 unless there will not be a displacement along the direction of force or opposite to the direction of force. There will be no work done. So answer for this is 0. Let us move to last question now. If a stone of mass m falls for a vertical distance d, the decrease in gravitational potential energy is. Now, at this, your potential energy is mgd. I have not taught you about potential energy. Simply definition I had given you. Right? Potential energy will have 2 distinct definitions. One definition you will be considering energy possessed by body due to its position. Usually it is applicable for a particle which may not have any dimension. If a particle of mass m is situated in gravitational field, so due to its position, suppose I will take a stone, I will keep to a height h, whatever energy it will possess, that will be your gravitational potential energy. I have a charged particle, it is situated in an electric field, guaranteed it will have potential energy. Right? Second will be energy possessed by a body hidden in the configuration of the system. Means now particle concept you will not consider. You will be considering dimension of the system. Actually potential means hidden. You check dictionary. The hidden energy is known as potential energy. We are not telling, my dear child, you have lot of potential. What do you mean by that? You have lot of hidden talent. So energy hidden in the configuration of physical system is also known as potential energy, like energy is stored in a stressed or compressed spring. We will learn all these in detail when you will be coming here. At this time, you are taking energy possessed by the stone when it is situated in a gravitational field. It is situated at a height d. Potential energy is mgd. Stone is falling So vertically displacement is decreasing. So decrease in gravitational potential energy will be m. Already they are telling you decrease. So no minus sign again. So decrease in gravitational potential energy will be here mgd, force into displacement. Okay. So answer simply equal to mg into d. Clear to you? You check this. We have completed work power energy, every problem, classwork and homework. And with this, we are concluding these classes. Again, we will meet when you will be coming here, right? Further, again from the beginning we will start learning not only physics. First we will be learning mathematical tools, math, differential integral calculus and all, and after that we will start physics in too much depth. This one was, all these classes were simply for giving you fundamental basic concepts, so that when you will be coming near to us, you will not face any difficulty in understanding. Okay? Now you will have 10 minutes break. After that your math class will start. Thank you to all of you. Have a nice day. Again we will meet when you will come near to us. Thank you again.
Good morning, students. So as discussed yesterday, we'll be doing questions on worksheet 19 and 18 also. Okay. So first let's discuss 19 and then we'll be doing remaining questions of 18. Okay. So let's start with the first question. In a class of 60 students, 25 students play cricket and 20 students play tennis, right? And 10 students play both. Okay. So let's say the universal students is equal to what? Cricket, union, tennis, right? So in the class, at least every student play at least one game, okay? Either cricket or either tennis, right? And how many students are playing cricket? Cricket is how much? 25. And tennis is how much? 20, right? And both of them, cricket and tennis, how many are playing? 10, right? How many are playing? 10, right? So they are saying the number of students who play neither. Neither means it is not equal, right? This is not equal, okay? And U is given to be 60, right? And U is given to be how much? 60, right? What are we finding? They are asking us to find N of C union T complement, right? N of C union T complement. So for that, what will I do? I will first find C union T, right? So to find C union T, what I'll do? N of C union T is equal to what? There is a formula, N of C plus N of T minus N of C intersection T, right? N of C plus N of T minus N of C intersection T. We have all the values, so let's plug in here. So what I will get? 25 plus 20 minus 10, right? So this will be equal to what? 35, right? So number of students who are playing at least one of the game, right? Cricket or tennis. Cricket or tennis is how much? 35, correct? Now what they are saying? They are asking us to find N of C union T dash, and we know that N of C union T dash is equal to what? N of U minus N of C union T, right? What is N of U? N of U is 60. 60 minus 35, which is how much? 25, right? It is equal to how much? 25. So the answer for this is what? Option B, right? The answer for this is what? Option B. Okay, I hope this is clear to everyone, this first question of worksheet 19. Okay, then let's do the second question. In a town of 840 persons, 450 persons read Hindi, right? 450 persons read Hindi, 300 read English, right? And 200 read both, right? 200 read both. Again, they are asking the same thing, the number of person who reads neither, right? So similar question, right? They have given N of U in a town. How many people are there totally? 840. 840 are the people in the whole town, right? Now, how many of them are reading Hindi? N of Hindi is equal to what? 450, right? N of English. English is equal to what? 300, right? Number of people who are reading English, right, is how much? 300, right? And number of people who are reading Hindi intersection English, that is both, right? Both they have given to be how much? 200. So it is 200, right? Number of people who are reading both, correct? So we need to find what? We need to find N of H union E dash, right? We need to find N of H union E dash, correct? So how will I find this? First I need to find N of H union E, right? I need to find N of H union E, and what it will be equivalent to? It will be equivalent to N of H plus N of E minus N of H intersection E, right? N of H plus N of E minus N of H intersection E, right? How much is N of H? N of H is how much? 450, right? So I'll plug in it here. 450 plus N of English is how much? English is given to be how much? 300, right? And N of H intersection E, that is Hindi and English both, is given to be how much? 200. So it will be what? 200. 100. So I will be getting it to be how much? 550. Right? It will be getting it to be how much? 550. Correct? Now, but we are looking to, they are asking us to find this, right? H union E dash, right? We can also write it to be equal to like this, n of H dash intersection E dash, right? N of H dash intersection E dash. And this is equivalent to n of U minus n of H union E, right? N of U minus n of H union E. N of U is given to be how much? N of U is to be 840. So we can say it is 840, right, minus 550, right? So this will be equivalent to how much? 290, right? This will be equivalent to how much? 290. The correct option for this is what? Option B, right? The correct option for this is what? Option B, correct? I hope this is clear to everyone. Option B. Then next, third, in a group of students, 100 students knows Hindi, 50 know English, and 25 know both, right? So let's say in a group of 100 students, right? 100 students are there, so we'll say n of union is equal to what? 100, correct? 100 they are saying it is Hindi. Okay, this is mistaken, right? 100 are what? Hindi. So this is not n of U, this is n of H, correct? 50 know English, so 50, n of English is equal to what? 50, and n of both is how much? Hindi intersection English, it is equal to what? 25. It is equal to what? 25, right? Now what they are saying, there is a very important line in this question. What are they trying to say? Each of the students knows either Hindi or English, right? So at least one language every student knows, right? At least one language every student knows, right? So what is the meaning of the statement? That n of U will be equivalent to what? N of H union E, right? Hindi or English, right? N of H union E, right? N of U will be equal to n of H union E. And what is equivalent to? N of H union E is equivalent to n of H plus n of E minus n of H intersection E, right? N of H plus n of E minus n of H intersection E. So this will be equivalent to 100 plus 50 minus 25. So this is equal to what? 125, right? It is equivalent to what? 125. So how many students are there in the group? Total students are equal to what? 125, as they have given a statement that each of the students knows either Hindi or English, right? Hindi or English, at least one student knows, right? So that is why n of U is equal to what? N of H union E, correct? If n of U is equal to n of H union E, right? What can you say about n of H union E dash? N of H union E dash, right? How many students are there who will speak neither, right? 0, right? Because they have clearly mentioned that each student speaks at least one of Hindi or English, right? So that's why it will be what? 0. Okay. All right. I hope it is clear to everyone. Okay. Next. Fourth question, right? Fourth question. In a survey of 600 students in a school, right? 600 students in a school, 150 students were found to be taking tea, right? 150 were found to be taking tea. So first of all, they have given, there are how many students? 600. So n of U is given to be what? 600, right? Then 150 were found to be taking tea. So n of T will be equal to what? 150. The people who are found to be taking tea is how much? 150, right? And 225 are taking coffee. So n of coffee is equal to what? 225, right? N of coffee is equal to what? 225. 100 were taking both tea and coffee. So n of cricket intersection T is equal to what? 100, right? It is equal to what? 100, right? both. Find how many students were taking neither coffee or tea, right? There could be a students who are taking neither tea or coffee. So this is similar to the previous first two questions, right? Now the third one, right? What they are asking n of tea unions coffee complement. N of tea unions coffee complement. So it will be equivalent to what? We know it is equal to what? N of u minus n of tea union coffee, right? N of u minus tea union coffee, correct? Okay, now we need to find this n of tea union coffee. So it will be equivalent to what? N of tea union coffee is equal to n of t plus n of c minus n of t intersection c, right? N of t plus n of c minus n of t intersection c. What is n of t? 150, right? What is n of c? 225. And what is n of t intersection c? It is 100. It is how much? 100, correct? So what is the answer for this? This is, I guess, it is 275, right? It is how much? 275, right? Now if it is 275, what are they asking? They didn't ask us to find this, right? They are asking us to find how many will be drinking neither tea or coffee, right? So what I have to do, I have to substitute it here, right? So n of u is how much? 600. So the answer is 600 minus 275, right? 600 minus 275. And 600 minus 275 is how much? It is 325. Right? It is how much? 325. So the answer is what? Option A. Right? The answer is what? Option A in this case. Understood? I hope this is clear to everyone. Right? Fourth question. It is similar to the first two questions. Okay, it's a big question. Let's read it. In a survey, it was found that 21 people like product A. Right? 21 people like product A. So let's say n of A is equal to what? 21. 26 liked product B. So n of B is equal to what? 26. Right? And 29 liked product C. 29. So n of C is equal to what? 29. If 14 people liked product A and B, 14 people liked product A and B. So n of A and B means what? A intersection B, right? N of A intersection B. It is equal to what? 14. It is equal to what? 14. Right? Next. N of 12 people liked product C and A. They have given 12 people liked product C and A. So can I say from here that n of A intersection C or C intersection A, both is same, it is equal to what? 12. Right? It is equivalent to what? 12. Right? And 14 people like product B and C. So n of B intersection C is equal to what? 14. Right? What they are saying next? And 8 liked all the 3 products. 8 of them will like all the 3 products. So n of A intersection B intersection C is equal to what? 8. N of A intersection B intersection C is equal to what? 8. Right, next, find how many like the product C only. How many of them like the product C only? Okay, this is a very good question, right? So what are they saying? They want us A complement intersection B complement intersection C. Right? A complement intersection B complement intersection C. Correct? So let's draw a Venn diagram. Right? So if I draw a Venn diagram, right, let this be product A, people who like product A, people who like product B, and this be what? People who like product C. Right? Now what they are asking us to find the required area is what? This area. They are asking us to find this area, right? Now how to make this convert into a formula, right? How to find this area, right? While studying in Venn diagram, we have actually applied this, how to find the value of this area, right? If all the given information are there, right? So how will I find? For this, I have to remove if you see, I have to remove this area, right, and this area, right, this area and this area. What is this area? This area is what? B intersection C, right? What is this area? This area is what? A intersection C, right? What is this? A intersection C. And if you see this particular area, which is A intersection B intersection C, right, came once in C, right? It came once in C, but, right, it was subtracted once in A intersection C and it was subtracted once in B intersection C. So we will have to add it to get this area, right? Okay, so how will I do? For this, what will I do? It will be equivalent to, n of C, right? N of C minus n of A intersection B minus n of B A intersection C and minus n of B intersection C, right? A intersection C minus B intersection C, right? And since we have subtracted it once more time, so we'll add one more time n of A intersection B intersection C, right? I hope this is clear to everyone. Okay, so we have all the values. Let's plug in the value. What do we get? So what is n of C? N of C is 29, right? What is n of A intersection C? A intersection C is how much? 12, right? And what is B intersection C? It is 14, right? And what is this? It is plus 8, right? So 29 minus 26 is how much? 3. 3 plus 8 is how much? 11, right? How much it is? 11. So the correct answer for this is how much? 11, right? The answer for this is what? 11. Okay, I hope I am clear for this, right, everyone? This question is very interesting. Okay, this was different from all the other 4 we have done. This was a very interesting question. Okay, I hope this is clear to everyone. Right, next. 6th. In a committee, 50 people speak French, 20 speak Spanish, and 10 speak both Spanish and French, right? How many speak at least one of these 2 languages? How many speaks at least one of these 2 languages, right? So what they are asking us to find, they are asking us to find n of French Union Spanish, right? N of French Union Spanish, right? So how will I find this? It will be the simple formula, n of French plus n of Spanish minus n of French intersection Spanish, right? And they have given us all the value, right? So what is n of F? If I write it here, what is n of French? N of French is equal to what? 50, right? What is n of Spanish? Spanish is equal to what? 20. And what is n of French intersection Spanish? It is what? 10. Right? It is what? 10. So if I plug in all the values, what will I get? It will get 50 plus 20 minus 10, which is equal to what? 60. Right? Which is equivalent to what? 60. The answer for this is what? B. Right? The answer for this is what? Option B. Right? I hope I am clear with this to everyone. Right? Very simple question. Next. In a group of 65 people, 40 like cricket and 10 like both cricket and tennis. Right? How many like tennis only and not cricket? And how many like tennis? I think this question we have already done. Right? There are 2 parts in this. I think we have already done this question. How many like tennis, right? So there are 65 people, right? So n of universal side is equal to what? 65. 40 like cricket. So n of C is equal to what? 40. 10 like both. So n of C intersection T is how much? 10. Right? How many like tennis only and not cricket? So assuming that at least one sport each of them, right? Then only we'll get the answer, right? So what they are asking us, they have given us that it is n of C union T is equal to what? 65. N of C union T is equal to what? 65. So what is missing here? Missing is n of T. Right? So I can just apply the formula. right? What will be the formula? N of C union T is equal to N of C plus N of T minus N of C intersection T, and N of C plus N of T minus N of C intersection T. What is N of C? 40. Plus N of T is how much? We don't know. We need to find. Right? And N of C intersection T is how much? 10. Right? And N of C union T is given to be how much? 65. Right? So 65 is equal to 30 plus N of T. So N of T is equal to what? 35. Right? N of T is equal to what? 35. Right? But they are asking us how many of them like tennis and not cricket. Right? Tennis only. Right? How many of them write at tennis only? So for tennis only, what they're asking, N of cricket complement intersection T. Right? N of cricket complement intersection T. So for that, what you have to do? N of T minus N of cricket intersection T. Right? N of T minus N of cricket intersection T. So that will be equivalent to what? 35 minus 10, which is what? 25. Right? N of 35 minus 10. So if through Venn diagram, if I need to explain, right, they are asking us to find this part. Right? So for this, what did I do? Tennis and cricket. What did I do? I separated this part from the tennis part. Right? So that's what I got the answer to be what? 25. Right? I hope it is clear. This is not the question. They have asked the two part, but this is not the part of the question. Right? This we need to find tennis and only and not cricket. Right? I hope I am clear with this. Okay, next. 8th question. In a group of 70 people, 37 like coffee. Right? In a group of 70 people, 37 like coffee. It's similar to the one we have done this right now. 52 like tea, and each person likes at least one of the two drinks. Right? What is the meaning of this line? Each person like at least one of the two drinks. It means that N of U is equal to N of T union coffee. Right? What they are trying to say? N of U is equal to N of T union C, and this is equivalent to what? This is equivalent to what? 70. Right? This is equivalent to what? 70. Right? If it is equivalent to 70, right? What I can say? N of T union C will be equal to N of T plus N of C minus N of coffee intersection T. Right? So this is, they have given 37 like coffee and 52 like tea. Right? Okay. So what I can write? I can write 70 is equal to 37 plus 52 minus we need to find N of coffee and tea both. Right? Coffee and tea both. So this will be equivalent to what? This will be equivalent to 3589. Right? Minus N of C intersection T. So can I say N of coffee and tea is equal to 89 minus 70, which is what? 19. Right? 89 minus 70 is equal to what? 19. So the answer is what? Option D. Right? The answer is what? Option D. Right? I hope I am clear for this 8th question. 9th. Okay. In a survey of 400 students in a school, 100 were listed as taking apple juice, right? 150 as taking orange juice, and 75 were listed as taking both apple as well as orange juice, right? Then how many students were taking neither apple juice nor orange juice? Neither apple juice nor orange juice. Okay, simple. So what will I do here? 400 students in a school, right? So I can say N of universal is equal to what? 400. Correct. How many were drinking apple juice? Apple juice is how much? 100. Right? How many were drinking orange juice? N of orange is how much? 150. And how many were drinking apple intersection orange? 75. Right? How many were drinking apple intersection orange? That is, both of them is 75. Right? What we need to find? We need to find N of apple union orange complement. right? N of apple union orange complement. So it will be equivalent to what? N of U minus N of A union U, right? As we have done in the previous questions, right? So we need to find this. So N of A union O, right? That is apple or orange will be equal to what? N of apple plus N of orange minus N of apple intersection orange, right? Minus N of apple intersection orange. What is N of apple? It is 100. What is N of orange? N of orange is 150 minus this is what? 75. So it is how much? 175. Right? It is how much? 175. Right? So, but we didn't need to find this. What we need to find? We need to find N of universal set minus N of A union O. So what is N of universal set? It is equal to what? 400 minus 175, which is how much? 225. Right? Which is how much? 225. So the answer is what? Option C. Right? The answer is what? Option C. Correct? I hope I am clear with this one. Right? Next. 10th. From 50 students taking examination in mathematics, physics and chemistry, each student has passed in at least one of the subjects. What does it actually means? 50 students taking and all of them at least one of the subjects. So it means that N of universal set, which is 50, is equal to what? N of physics union chemistry union maths. Right? N of physics union chemistry union maths. Right? And for mathematics, how many of them has passed? N of M is equal to what? 37. Right? N of physics is how much? N of physics. Physics is how much? 37, 24. Right? And N of chemistry. N of chemistry is what? 43. N of chemistry is what? 43. Right? Now, what they are saying next? They are saying at most 19 passed mathematics and physics. Right? So I can say N of mathematics intersection physics is equal to 19. N of mathematics and chemistry. Mathematics intersection chemistry is what? 29. Right? And at most physics and chemistry. Physics and chemistry is equal to what? 20. Right? What is the largest possible number that could have passed all the three examination? It means they are asking us to find M intersection P intersection C is equal to what? Right? So it's simple. What will I do? I will write the formula for this. Right? What is the formula? The formula is N of P union C union M is equal to N of M plus N of P plus N of chemistry, right? Minus N of M intersection P minus N of physics intersection C minus N of chemistry intersection M, right? Plus N of M intersection P intersection C, right? So if I write it here, how much it will get? I'll get 37 plus 24 plus 43, right? Minus 19 minus 29 minus 20 plus N of M intersection P intersection C. This is how much? 50. This is how much? 50, right? So from here I can get the value of this. N of M intersection P intersection C. How much it is? Oh, see, 37 plus 43 will be how much? 80. 80 plus 24 is how much? 104. Right? 104 minus 19 plus 19 and 29 is how much? It's going to be 48. 48 and 20 is how much? 60. 68. Right? 68 plus N of M intersection P intersection C. Right? Now, 104 minus 68. Right? 104 minus 68 will be how much? 36. Right? 36 plus N of M intersection P intersection C. Right? If I send it this side, so I can say that from here I'll get N of 104, right? What is the largest possible number that could have passed all the? I think we are getting the answer is 7. 50 minus 33, we are getting the answer as 14. Right? Let me check the calculation once again. 37 plus 43 is 80. 80 plus 24 is 104. And this is 19 and this is 29. Right? So 19, 29 and 20. So this is 38, 38 and this 48. 48 and 20 is 68, correct. I guess this is 36, right, correct. So n of m intersection p intersection c is equal to number 14, right? That has to be the answer. I don't know why they have not given. The answer should be how much? 14, right? Okay, next. This is a very interesting question. A survey shows that in a city that 63% of the citizens like tea and 76% like coffee. If X% like both tea and coffee, then X is equal to 63, X equal to 639, or X is lying between this, right? So see, let's assume this is a city, right? So to get the minimum, what I can say, out in this city, 76% like coffee, right? 76% like coffee. So let this be the part of people who like coffee. Right? 76% like coffee. This is coffee, right? And for minimum, right? X to be minimum, right? What I should say? For X to be minimum, T has to be lying on the same side, right? T has to be lying on the same side, and it is equal to what? This will be equal to what? 63, right? 63, right? So this whole is 76, right? And this is how much? 63, right? So how many of them like both? Both of them likes how much? 63. So X will be equal to what? 63. This is X max, right? This is X max, right? For minimum, the diagram will be different, right? For minimum, the diagram will be different. How much it is? This is 76, sorry, right? And T in this case will be lying on this side, right? T in this case will be lying on this side. So it is how much? This is equal to what? 63. So the common area will be this part, right? The common area will be this part, and this will be how much? 76 minus 63, which will be how much? 39, right? It will be how much? 76 minus 63, which will be how much? Wait a minute, not 76 minus 63. Okay, so this question has to be done in what way? See, this is how much? 76. This is how much? 76. So what is this area? This area is 100 minus 76, right? This is how much? 100 minus 76. So it is equivalent to what? 100 minus 76 is what? 24, right? 100 minus 76 is what? 24. So this blue part will be what? 63 minus 24, which will be how much? 39, right? 63 minus 24, which will be what? 39. So it means that X minimum is equal to 39 and X maximum is equal to what? 36. Sorry, 63. Right? So the answer is what? Option D. Right? The answer is what? In this case, option D. Right? I hope I am clear with this. Next, 12th. In a college of 300 students, every student reads 5 newspapers and every newspaper is read by 60 students. Then the number of newspapers are what? Okay. Very interesting fact about this question. This question have come in IIT exam, right? Very like a long back. Okay, I think in 1980s or 1970s, this question has appeared in IIT exam. And what it is asking, in a college, 300 students are there. Every student read 5 newspapers, right? So how many times the newspaper is read, right? 300 students, right? Into number of newspaper, how many? 5. So it is equal to what? 1500, right? And every newspaper is read by 60 students. What they're asking, number of newspaper. So let's say it is equal to X. Number of newspaper is equal to what? X. If it is equal to X, and it is saying each newspaper is read by 60 students. So total number of times newspaper is read is equal to how much? 60 into X. Right? It is equal to what? 60 into X. So can I say from here 1500 is equal to 60 into X? Right? So X will be equal to what? X will be equal to 1500 divided by 60. This and this will be cancelled. Right? So this will be how much? 25. Right? So the answer is what? Option B. Right? The answer is what? Option B. Right? I hope I am clear with this one. Right? Next. In a town of 10,000 families, it was found that 40% of families buy newspaper A. Right? 20% of families buy newspaper B. And 10% of families buy newspaper C. Okay, 5% of families buy A and B, right? And 33% buy B and C. 4% buy A and C. If 2% of families buy all the three newspapers, then number of families which buys newspaper A only. Right? This type of question, yes, we have done, right? In physics, chemistry, maths, I guess. And they have asked N of C only, right? So, similarly, if I draw the Venn diagram here, right, this be A, this be B, right, and this be C. Right, this be A and this be B and this is C. Right? So what they are asking? Okay, I think this question is of the next part. So what they are asking this part. Right? Only A only. So for N of A only, what I'll do? N of A, they are asking N of A intersection B complement intersection C complement, right? A intersection B complement intersection C complement, which will be equal to what? N of A minus N of A intersection B minus N of A intersection C plus N of A intersection B intersection C, right? And how many of them are reading newspaper A? It is 40. So 40 minus A and B are reading 20. Right? And A and C, no, 20 is not that. A and B, 5% of by A and B. So it is 5. Right? This is 5. Right? And A and C is how much? 4%. So it is 4. Right? And 2% is this. So this will be equivalent to what? 40 minus 7. So it is 33. Right? 33% of people are reading newspaper A only, right? So 33% of what? 33% of 10,000. Right? So this 2 will be going. So answer will be what? 3,300. Right? The answer will be what? 3,300. Right? So the answer is what? Option C. Right? I hope I am clear with this. Okay. Next. Okay. There is a half part here only. Let's understand. In a group of 1,000 people, there are 750 people who can speak Hindi and 400 who can speak Bengali, right? So I will write it here. Total number of people are how many? N of universal is how much? 1,000, right? N of Hindi is I think 750 and N of Bengali is how much? 400. N of Bengali is how much? 400, right? And who can speak Bengali? Okay. Okay. All right. What they're asking, how many people can speak Hindi only, right? So they didn't give us one information, but I think this has to be assumption that at least one language every person in the group speak, right? Hindi or Bengali. So if it is the case, I can say N of U, right, is equal to what? N of Hindi union Bengali, right? N of U is equal to what? N of Hindi union Bengali, and it is equal to what? N of H plus N of Bengali minus N of H intersection B. Right? So it will be equal to what? 1000 is equal to 750 plus 400 minus N of H intersection B. Right? So can I say N of H intersection B is equal to 150 minus 100. So it is what? 150. It is what? 150. Right? But they are not asking this. What they are asking, they want us to find Hindi only. Right? So Hindi only. Right? This be Hindi, this is Bengali. Right? So this part they are asking. For this, what I need to do, I need to subtract this part, right, from Hindi. So they are asking us to find N of Hindi intersection Bengali complement, which will be what? N of Hindi minus N of Hindi intersection Bengali. Right? What is N of Hindi? N of Hindi is 750 minus 150. It is equal to what? 600. Right? It is equivalent to what? 600. So the answer is what? Option D. Right? I hope I am clear with this. Next question. How many speak Bengali only? So in this case, what they are saying, N of Bengali intersection Hindi complement, which will be N of B minus N of Hindi intersection B. Right? N of B is how much? 400 minus 150, which is how much? 250. Right? Which is how much? 250. So the answer is what for this? B. Right? And last question. How many can speak both Hindi and Bengali? This we already found. This is equal to what? Option C. Right? So this marks the end of worksheet number 19. Right? Now we'll do the remaining question of worksheet number 18, which we left yesterday, and then we'll be ending the lecture. Okay? Just give me a minute. I'll open worksheet number 18. Okay, so let's start worksheet number 18, the remaining 10 or 12 question, whatever it is there. We'll discuss this and then we'll end the lecture, right? Okay, what is it saying? N of A is this. Oops. N of A is 50, N of B is 20, and N of A intersection B is 10. Then what is N of A symmetric difference B, right? So N of A delta B is equal to N of A plus N of B minus N of twice of N of A intersection B. Right? So what is N of A? N of A is 50. This is 20 minus this is 2 into 10. So it will be how much? 50. Right? So the answer for this is what? Option A. Okay? It was pretty simple. Not much. Just we need to know this formula. Right? It's very clear. Next, question 7. If A and B are two sets such that N of A is equal to 70, N of B is 60, N of A union B is 110, then what is N of A intersection B? Right? So we know the formula. What is the formula? N of A union B is equal to N of A plus N of B minus N of A intersection B. Right? What is n of A union B? Given to be 110. N of A is 70 and n of B is how much? 60. Minus this we don't know. Right? This we don't know. So can I say n of A intersection B is equal to 70 plus 60 is how much? 130 minus 100, which is 30. Right? Which is equal to what? 30. N of A intersection B. I don't know why it is not in the option. The answer is what? N of it is 30. Right? 130. So it is 110. Okay, so it is 20, right? It is 20. The answer is D. It was not 100, it was 110. So it is what? D, 20. Okay? Right. Next question. If sets A and B have 3 and 6 elements each, then the minimum number of elements in A union B, right? Minimum number of elements in A union B, right? So for minimum, right? Minimum number of elements in A union B. What can I say? See, there are two possibilities. B is the bigger set here, right? B is the bigger set, right? If A union B has to be minimum, n of A union B has to be minimum, then A has to lie completely inside B, right? A has to lie completely inside B, right? So in that case, n of A union B will be equal to n of B, which is nothing but 6. Which is nothing but 6. But if they are asking us n of A union B maximum, right? It means that in this case, both of them will be lying completely outside, right? There will be nothing common between them. So this is 3 and this is 6. So for this case, it is how much? 9. Right? For maximum, it will be how much? 9. But they are asking in this case minimum. Minimum means what? Option B. Right? Minimum is what? Option B. Right? Next question. 9th. If n of U is 700, n of A is 200, n of B is 300, and n of A intersection B is 100, then what is this equivalent to? Right? So this equivalent to n of A complement intersection B complement is equal to what? N of U minus n of A union B. Right? What is n of A union B? N of A union B is equal to n of A plus n of B minus n of A intersection B. Right? N of A plus n of B minus n of A intersection B. So what is n of A? It is 200 plus 300 minus 100, which is equal to 400. Right? Which is equivalent to what? 400. Right? Now what they are asking? They are asking us to find this, which will be equal to what? 700 minus 400, which is 300. Right? The answer is what? Option C. Right? The answer is what? Option C. Right? Hope I am clear for this. 10th. N of U is equal to 48, n of A is 28, and n of B is 33. Right? And n of B minus A is equal to 12. Okay. So what is n of B minus A? B minus A is equal to n of B minus n of A intersection B. Right? This is, they have given to be how much? 12, and n of B is how much? 33. So this is n of A intersection B. From here, I can get the value of n of A intersection B, which is what? 33 minus 12, which is what? 21. Right? This is 21. What they are asking? A intersection B complement. So n of A intersection B complement will be what? N of U minus n of A intersection B. Right? What is n of U? N of U is how much? 48 minus 21, which will be 27. Right? Which will be 27. So it is option A. Right? It is what? Option A. Right? Pretty simple question. Next. 11th. If n of A intersection B complement is equal to 5, right? That is nothing but n of a minus b is equal to 5, n of b minus a is equal to 6, right? And they have also given n of a intersection b, which is what? 4. What are they asking? They are asking us to find n of a union b, n of a union b. So n of a union b is equal to n of a minus b plus n of b minus a plus n of a intersection b, right? All of them, because for union, what I have to do, they have given us all the three parts, this part, and this. All right, so it will be equivalent to what? 5 plus 6 plus 4, which will be what? 15, right? Which will be equal to what? 15. So the answer is what? Option B, right? The answer will be what? Option B, right? I hope I am clear with this. Next, 12th. Let n of a minus b is equal to 25 plus x, n of b minus a is equal to 2x, and n of a intersection b is equal to 2x. And they have given one more information, that n of a is equal to twice of n of b, right? So n of a is equal to twice of n of b. What is n of a? N of a will be n of a minus b plus n of a intersection b, right? And what is n of b? Twice of n of b plus, sorry, n of b minus a plus n of a intersection b, right? So what is a minus b? A minus b is 25 plus x. What is this? This is 2x. It is equal to twice of, what is b minus a? B minus a is also 2x. And this is plus 2x, right? So this will be how much? 25 plus 3x is equal to 8x, right? So I can say 25 is equal to 5x. So x will be equal to what? 5. Right? X will be equal to what? 5. So the answer for this is what? Option B. Right? The answer for this is what? Option B. Right? I hope I am clear with this. Next, 13. A set A has 3 elements and another set B has 6 elements. Then this question we just now we discussed for minimum and maximum. I told you for minimum the condition should be what? That A has to lie completely inside B, right? And for maximum, A and B should be outside. This should be this is be A, right? So in this case, n of A union B will be equal to 6, which is n of B, right? And this case, n of A union B is equal to n of A plus n of B, which will be equal to 3 plus 6, which will be equal to 9. Right? It will be equal to what? 9. So the answer for this will be what? C. Right? 6 and 9. Correct? Next. Okay. This question, this type of question also we have done. Suppose A1, A2, A30 are 30 sets having 5 elements, and B1, B2, B2 are what? N elements. Right? So how many elements in S is there? S will be how much? 30 into 5. Right? And B, from side B, it will be how much? 3 into N. Right? But exactly how many 10 of the elements belongs to AI? Right? And exactly 9 of them belongs to B. So what I can say, this if I divide by 10 and this by 9, this will be what? Equal. Right? Okay. So from here I can get the value of N. N is equal to what? 45. Right? N is equal to what? 45. So the answer is what? Option C. Right? The answer is what? Option C. Right? Then next. I guess this is the last one. Okay. If x is equal to a to the power n minus 7n minus 1 and y is equal to 49n minus 49, then what is the subset relation? Okay. So if I put n equal to, oops. if I in x, if I put n equal to 1, right, n equal to 1, what do I get? N equal to 1, if I put, I'll get 0, right? If I put n equal to 2, right, and if I put n equal to 2, I'll get 64 minus 14, which is 50, 50 minus 1 is 49, right? Then if I put n equal to 3, right, and if I put n equal to 3, so what I'll say, n if I put 3, what I'll get? 8 to the power cube, right? 8 to the power cube is 512, right? 512 minus 21, 512 minus 21 minus 1, right? So this will be how much? This will be 22. So it will be 490. It will be what? 490. So 0, 49, and directly what it is? 490, right? And so on. But in case of y, if I put n equal to 1, I'll get 0, right? If I put n equal to 2, I'll get 49. If I put n equal to 3, I'll get 98. I'll get what? 98, and so on, right? And after a while, I'll be getting 490 also, right? So which one is the bigger set here? Which one is the bigger set? In x, 0, 49, and directly 490, right? In y, 0, 49, 98, and so on. Multiple of 49 is there till, and there will be after 490 also, right? So which one is a bigger set? Y is a bigger set here, right? And x is a part of it, right? X is a part of it. So I can say x is a subset of y. So the answer is what? Option A, right? The answer in this case is what? Option A, right? So I think this marks the end. Right, this marks the end of worksheet 18 and 19 and the CBC 2 also. Okay. I hope all the questions are clear and everything theory is clear to all of you, right? So see you in the classes, okay, offline. All right. Any of you have any doubt, you can go to the centers and visit the faculties there. They will be available from 2 to 5 o'clock. Okay. Thank you, everyone. Okay.